everyone, myself Pavan, studying at Sri Venkateshwara College of Engineering, 3rd SEM, Section Bhaskara, course title Operating System, course code BCS 303, topic Develop a C program to simulate banker's algorithm for deadlock avoidance. Mastering resources harmony, simulating the banker's algorithm for deadlock avoidance in C. Introduction. In this presentation, we will explore mastering resources harmony through the banker's algorithm. This algorithm is crucial for deadlock avoidance in operating system. By simulating this algorithm in C, we can implement or enhance the understanding of resources management and ensure the system stabilities. Understanding deadlocks. A deadlock occurs when two or more processes are unable to proceed because each are waiting for other to release resources. Understanding this concept is virtually implementing effective deadlocks. Avoidance statistics using the banker's algorithm. The banker's algorithm. The banker's algorithm is a resources allotted for the deadlock avoidance algorithm that tests for the step sets. It ensures that the system can be allotted resources through the processing without enhancing a deadlock situation, simulating a real life banking scenario. Key components of the algorithm. The algorithm involves several key components, process and resources, max demand allocations and available resources. Understanding these components is essential for the simulating the algorithm in effective in C. Setting up the simulation. To simulate the banker's algorithm in C, we need to define the data structure, if process and resources. This includes the array to maximum resources, allotted resources, and available resources to track the system state. Implementing the algorithm. The implementation is involved in creating functions for checking safety, requesting resources, and releasing the resources. Each function plays a vertical role in ensuring that the system remains in safe state throughout resources allocation. Simulating resources request. In our simulation, we demand will be demonstrating how the process requests resource and how the algorithm checks if the resource can be granted without leading the deadlock. This dynamic interaction is key to understanding the resource management. Handling resource allocations. Once a resource is requested is made, the algorithm enables the system state. If its request can be safely allotted, the state is updated. This process highlights the importance of real-time decision making in resource management. Testing for safe states. After resource allocation, the algorithm checks the safe state by simulating the computing of the process. If the state process can find without causing deadlock, the allocation considered safe. Ensure the system reliability. Here the simple resource code for the banker's algorithm where character job is equals to 10 and int time is equals to 10, available temp 10 and temp p 10, and printf the statement as the enter the number of jobs, and for I is equal to 0 I is less than n and I plus plus, printing of the statement as the enter the name and time of the jobs where I is plus 1 for time and job, and initializing the temporary array for sorting. For I is equal to 0 I is lesser than n, for I is equal to plus, and sorting the job by the time in ascending order. For I is equal to 0 and j is equal to 1, I is equal to j is equal to n and j plus plus, where the temp of I is greater than temp of j, and checking for the safe sequence. For I is equal to 0 I is lesser than n and I is equal to plus plus, where q is equal to temp of I. For checking the safe sequence where q is equal to temp of I and and resourcing the available resource. For after selecting printf the statement of job is safe index, and incrementing the index for the safe sequence, and printing of the no safe sequence for I is equals to factorial of is equals to n, and some code explanation where changes initializing the int set is equals to 0 and begin to adding the job for beginning the safe of sequence of the array. Job input added a clearing promoting the enhancing jobs for names and times. Sorting logics, the sorting algorithm arrays jobs and executing time. This uses to selecting the jobs and incrementing the order for execution time. Safe sequence generation, the job selection for new checking jobs can be complete for the available resources, availing the then the updating available and to add a job for the safe sequences. Safe sequence check. After the loop, if int does not equals to n, it means not at all the all job were scheduled. We print no sequence scheduled. Final output. The sequence of safe sequence printed in the human reliable form showing that the job name and its execution time. Challenges in simulation. Simulating the banker's algorithm can be present challenges such as managing complex resources, requesting and ensuring the accurate state tracking. However, overcoming these challenges ensure the understanding of the resource harmony and system stability. Real world application. The principle of Banker's algorithm enhance the beyond the theoretical simulations. They are applicable in the operating system, database management, and network resources allocations, making it a virtual concept in modern computing. Conclusion and future works. In conclusion, mastering the Banker's algorithm is essential for achieving resource harmony in computing. Future works may involve in optimizing the algorithm and exploring its applications in more complexity system to enhance the efficiency. Thank you for watching my video.